Hi, grade 9, it's Mrs. Florenza again. Today I'm going to explain breathing, or it's known as ventilation, and this is on page 56 and 57 of your workbook. And please always look at Google Classroom to see what tasks need to be completed each day. All right, so let me share the PowerPoint on my screen. And obviously there's also short internet video. You need to go and look at that as well. All right, so here is breathing. It's otherwise known as ventilation. So this diagram shows that when you inhale, when you breathe air in, then your chest cavity is going to move out and up. Take a deep breath. Out and up. Okay, that's what the arrows over here show. And when you breathe in, the diaphragm, the dome-shaped diaphragm, it contracts and it flattens. So it's all about creating more space inside the chest cavity for the lungs to inflate. Okay, then exhalation is on the right-hand side here. So just take a deep breath and then breathe out. And you can feel how your chest, your thorax moves in and down. All right, so you can see the arrows, they're going in and down. So you breathe out. Chest cavity moves inwards, chest moves inwards and downwards, and the diaphragm, which was contracted and flattened, relaxes and becomes more dome-shaped. You can see now there's less space in your chest. If you look over here, there was more space for the lungs to expand or inflate, and here now there is less space. The volume is smaller, so air is going to be pushed out of your lungs. So just to mention again, the lungs are not made of muscle. It's the action of the rib muscles pushing the rib cage in and the diaphragm moving up. And then when you breathe in, the rib is pulled outward by rib cage is pulled outward by muscle action, and the dome-shaped diaphragm contracts and flattens, and that creates more volume in your chest for the lungs to expand. And you need less volume in your chest cavity to push the air out of the lungs. Right, so this is a nice side view. So inhalation or breathing in, person is breathing in here, and what happens is there, in between your ribs, there are rib muscles. They've got a fancy name. They're called intercostal muscles. You don't need to remember that, but those muscles contract and they pull the rib cage up and out. So you can see over here, the rib cage has moved up and out, and that dome-shaped diaphragm has contracted, moved down, flattened. So you can see how more space is made for the lungs to inflate. But when you exhale, the right-hand diagram here, that diaphragm has now, it was tight, it was contracted, so now it relaxes and it becomes dome-shaped, which you can see over here. And you can see that the rib muscles relax. They were contracting and pulling the rib cage up and up. Now they relax, and you can see how the rib cage moves in, all right? And then that creates a smaller volume in your chest cavity, and it pushes against the lungs, and you breathe out. All right, the lungs are not made of muscle. And it's basically due to pressure changes, and the reason why the air moves in and out as well. And that is what I want to explain to you. So I have a little model here. All right, if you just go back to full screen again. All right, so here's my little model. It represents some parts of the respiratory system. So at the top here, you can see the trachea and how it would branch. It's a little plastic tube, and how it would branch to form the two bronchi. And then you can see the two plastic sacs. They represent the lungs. And here you've got the rib cage. But that rib cage can't move in and out. Okay, it's made of plastic. So that's the only limitation, or one of the limitations of the model. And then at the bottom here, there's a rubber sheet. Okay, and that represents the diaphragm. Now you can make these if you go onto the internet, and if you Google plastic bottle lung model, you can make one of these. You can use the the top half of a cool drink bottle. You can have a straw going in through the lid, a little hole that you cut in the lid, and you can use one balloon just to show how that lung would actually work. And then the bottom here, you can, over the cut end of the bottle, you can just take some plastic. So use some tape, tape a bit of plastic bag or something over the bottom, and then you can pull it down and move it up. All right? So when you breathe in, okay, the lungs inflate. So if you just look here, I'm going to let the model breathe in. So inflate, lungs inflate, and then when you breathe out, the lungs deflate. Okay, they don't contract, they're not made of muscle. All right, so it's due to air pressure changes. So when you breathe in, the lungs need to inflate. There needs to be more space so that air can rush in. All right, and that happens because our chest moves up and out, and that's not shown here. But if you look at this rubber sheet, okay, there I'm pushing it up. That's trying to represent the dome-shaped diaphragm when it's relaxed. And then when I pull it down, it flattens. So in us, the diaphragm is dome-shaped. When it contracts, it flattens. So it's making more volume inside and more space for the lungs to inflate. All right, so there's the dome-shaped diaphragm. If I make it flatten, the lungs inflate. You can see how air moves into them. And if I push it up, pretending that our diaphragm was contracted, so now it relaxes and becomes dome-shaped. So now there's less volume inside there, and it pushes against the air inside it, pushes against the lungs, and it forces the air out. Okay, just watch again. So there's the diaphragm is dome-shaped, relaxed, flatten, lungs inflate. Push up, lungs deflate. Flatten, lungs inflate. Okay, so when you inhale, let's try and do this. And when you inhale, the volume inside here increases because the diaphragm flattens and moves down. So now there's more volume. And your rib cage also moves up. So there's more volume inside. So if volume is higher, pressure is lower. So the atmospheric air pressure on the outside is lower. So air rushes in to fill the lungs. I'll say that again. So when you inhale, the diaphragm contracts and flattens. The rib cage moves up and out. And the atmospheric air pressure is lower here. So it rushes in to fill the lungs. Because inside your chest cavity, the volume has become bigger because the diaphragm flattens and the rib cage moves up. So if the volume inside here is bigger, the pressure inside here is lower, the atmospheric air rushes in. Higher pressure outside to lower pressure inside. Just like diffusion, okay? When you breathe out, that contracted diaphragm relaxes and becomes dome-shaped again. So watch again. Dome-shaped. So now the space inside here is less and your rib cage also moves in. We can't show that here though. So the volume inside here is lower. The pressure is higher. So that is going to push against the lungs and the air with CO2 is going to be forced out. Just watch it again. So diaphragm flattens and moves down, lungs inflate. They become bigger, okay? That's breathing in, up, exhalation, the diaphragm relaxes and becomes dome-shaped. So therefore, air is forced out of the lung. Okay, watch again. Down, inflate. Up, deflate. Down, inflate. Dome-shaped, deflate. So, okay, and I hope that explains that. So now on page 56, you can see here inhalation and exhalation. Now, just one thing that I need to mention is when you inhale, the muscles of your ribs are contracting and pulling the rib cage up and out, and the dome-shaped diaphragm, it contracts and flattens. So that's it's an active process. Okay, that's the word I was looking for. It's an active process. Rib cage is active. It's being pulled out by the contracting rib muscles, and the diaphragm is contracting and flattening. But exhalation, the rib cage simply, the muscles relax and the rib cage goes back to normal, and the diaphragm was contracted in seconds, so now it just relaxes and becomes dome-shaped again. All right, so that's the level that we do in grade 9. There are other muscles attached to the ribs that are involved, but we're not going to do that. Okay, so inhalation, rib muscles contract and pull the rib cage up and out. Diaphragm muscles contract and the diaphragm flattens. So inhalation is an active process and the lungs inflate. Exhalation is passive. The rib cage muscles, they were contract, they relax, and the rib cage moves in. The diaphragm was contracted, it relaxes and becomes dome-shaped. So it's a passive process. So then the air is forced out of the lungs. Okay, so then you are going to complete task 3, explaining how the little model works. All right, and you are going to complete task 5, where you need to compare what happens to all these different parts during inhalation and exhalation. And then there's some other tasks on the next page. But go and look at Google Classroom, please.